Okay, so we're going to do example. We're going to do example 22 from chapter 3. So a debt of $15,000 is to be paid off with 12 semi-annual payments made starting 1 year from now. If the money is worth 11%, interest compounded semi-annually, find the size of each payment. So the first thing we're going to do is we are going to draw our timeline. Okay, now we know that it's starting 1 year from now. Payments start 1 year from now. They're semi-annual, so that's every 6 months. And we also know that we have the bit right here that says that it's paid off. Okay, so the paid off and a debt, those point us to A sub n and tells us that the $15,000 goes at the beginning, and then 1 year later we start payments, and then those are every 6 months. So our next one would be at 1 year, 6 months. And then our last one is over here. Now we already know that there's going to be 12 payments, so we know that n is 12. So we don't need an end date. It's not necessary to have. So no end date necessary. And again, that's because we know n, okay? So we also know that if we were to look at this piece, that A sub n, remember, goes right here. So this is our A12, goes right here at the 6 month mark. It'd be 1 period before our piece, okay? 1 period before it would normally happen, okay? So then we know n, we know that our interest rate is 11%, and that's compounded semi-annually. So that tells us that I is going to be 0.11 divided by 2. We know our n. We're trying to figure out r. We know this is not A12. It's going to be A12 deferred because we're 1 period before. So we know that A12 deferred is equal to 15,000. Okay, and we also know that we need P, because when we're using this deferred, we need a P. Okay, so there's 2 ways you can think about P. First way is it's going to be the number of periods from the money to your first regular payment, and then you subtract 1. Or you can think about it as the number of periods from the money to where A sub n would normally go. Okay, so if we go this route this time, then there'd be 1, 2 periods, so we'd have 2 minus 1, so we get 1, or we just jump 1 period, so that would be 1. Either way, P is 1. Okay, so when we set this up, we get 15,000 is equal to R times 1 minus 1 plus 0.11 over 2 to the negative 12, because that was our number of payments, over 0.11 divided by 2 times 1 plus 0.11 divided by 2, so our I again to the negative 1. So first thing we do is we have to figure out this whole mess, because that whole thing is our exponent. Okay, so when we do that, we can pull up our calculator here. Whoop. What just happened? It's already installed. Never mind. When you calculate that, you should get about 8.16 repeating. That's equal to your $15,000. Okay, then you divide by that answer. Whatever that answer is, or you could just write answer. We'll just stick with answer. That's supposed to be 15,000. So R is equal to 15,000 divided by the answer, and that should give you about $1,836.162. Now when we look at this, we want to round to the nearest penny, okay? Nearest penny would be this placement right here, okay? This is going to be the second decimal place that we're going to round to. Okay, so normally when we look at this, we'd want to round down because this is a 2, but because it's a payment, we're going to round up. So our final answer would be $1,836.17. Okay, so again, with payments, round up.